Hello guys, this is the question A of Codejam 2021. It's worth 7 points and it's called as reverse sort. So this problem is basically a brute force problem. So what this problem says is that you have a array of n elements and you have to sort that array in increasing order. So in order to sort that array, you can do a specific operation called as reverse sort. So what you do is that we sort certain subsections of the reverse certain subsections of the array in order to make the array sorted in increasing order. So how do we do that? We are given the algorithm for it. So what we are going to do is we are going from 1 to length minus 1 of the array, and we are going to find the minimum element between I and the length L, and then we reverse that section I and I to j. So what this does is that in each iteration it takes the minimum element and brings it to the front. So actually we are doing reverse. It's similar to selection sort. What we are doing, we are swapping the minimum element in selection sort. In reverse sort we are reversing the entire array, entire section of the array. So actually it's not needed, but since the algorithm is given like this, in order to sort this we have to use the reverse sort. So the question is not just to sort the array. Question says that there is a specific cost associated with each reverse operation. So the cost is given by j minus I plus 1. So what is this j minus I plus 1 cost? Actually j is the position of the minimum element in the subsection. So in order to understand that better, we shall take an example called with n equal to 5 and 3, 4, 1, 2, 5. This is our sample array. So when we are doing it in the first iteration, we will our I pointer will be in 3, in the section of 3. So 3 will be our I pointer, and we are going to search this section, this entire section for the minimum element. So the minimum element will be I. So 1. So what will I do is that we will swap this entire section of the array so that reverse the entire section of the array so that 1 will come to the first position. So what will be the case? It will become 1, 4, 3, 2 and 5. So that as you can see 1 came here. So then we go to the next element, that is 4, and then we search for the minimum element in this entire section. So here the minimum element is 2, and then what we do is that we swap this entire section of the array, reverse this entire section of the array, and what we get is 1, 2, 3, 4, 5. So as you can see, this array is already sorted. It's already sorted, but we don't know that actually if the array is sorted or not. So what we do is that we continue our operation. So our next element is 3. So what we do is 3 is that we check for the minimum element in this range. So the minimum element is 3 itself. So we swap this element. Actually the algorithm says to swap this element, but in practice we know that there is no reverse this element. We actually know that there is no reverse to actually do with one element of the array. So we leave it as it is, and then we move to our last element, which is 4. And we move to the 4 and we check this and we find that 4 is the minimum element, and then we leave it as it is. So what you can say, we don't need to check for 5 because since 1, 2, 3 first 4 elements are already sorted, the 5th element will also be sorted in the sorted correct position. So this is not the question. We are not asked to sort the array because this is not an efficient method to sort the array. If you want to sort the array, we can use selection sort. But the question is, what is the cost associated with it? So for each of these operations, there is a cost associated. The cost is given by j minus I plus 1. J minus I plus 1. So we have to find out this cost for this operation. So for this is j. J is the position of the minimum element. J is the position of the minimum element, the element where we find the minimum element, so which is 1. So here we got 1, which is at the third position. So we have 3 minus or I is the position, or is the current position which we check for. So which is the 1, where 3 is the current position which you are looking for, which you are looking for, and then we add 1. So the cost is actually 3. So here the cost is actually 1 2 3 4. 4 is the minimum elements position, and then we have 2. 2 is the current position, I is the position, and then we add 1, which is actually gives us 3 again. So here we have 3. 3 is the current position, and 3 is the minimum element also. So what you get is that the current position is 3, minimum position is 3, current position is also 3, and plus 1, which means it takes 1 cost. So actually there is no reversing happening here, but still we are accounting 1 cost. Why is that? That's how the algorithm works. Actually we don't need to reverse anything here. So here actually we are giving 4. So 4 minus 4 plus 1, which is actually 1. So actually what we can say is that if we sum all these the values, we get 8. So 8 is the total cost. 8 is the total cost associated with this entire operation. So we are asked to find this number 8. So the method to do this is fairly straightforward. You have to just implement this algorithm. So moving on to code. So in the code we have an integer n and reading the n, which is the size of the array, and a vector s which reads the array. Yes. So what we are doing is that we have cost assigned to 0, and from 0 to n minus 1, that is size minus 1, which is actually 1 to length minus 1 here, we find the minimum element from the I to the end of the from I to the end of the string, end of the array. So this minimum element j will have minimum elements position. So min element is a standard STL, C++ STL. So j will have the minimum elements position, and then we have asked to find the and then what we do is that we then reverse the array from I to j. Reverse the subsection of the array from I to j. So reverse is also a STL, standard template library function of C++. So what we do is that we reverse the subsection I to j, and what we have to do is that this j plus 1, why I have given j plus 1 is because this reverse function takes the starting pointer and ending pointer, and the ending pointer should be actually 1 greater than the actual ending pointer we have to do. So this s dot end will actually point to an element which is after the last element of the array. So if you want, it is actually 1 after the last, so that's why I given j plus 1, and then the cost will be cost plus equal to j minus I plus 1, which means that we are adding the cost, which is actually the formula j minus I plus 1. So we are outputting the cost and increment the test cases. So this was a fairly simple problem. So actually it worked very well because we have the standard STL library, so it was very easy, and it worked in time because the time limit was 10 seconds and the test case was 100, and the maximum number of inputs, the array size, maximum array size was actually 100, so it would work really well. So that's the question for 1. Hope you understood that question. So this question you can also read the input data in a sample test case here, which explains well what this question actually meant. Thank you.